Right. So now we are going to have a look at some of the questions, which are going to involve some proofs. And in addition to that, we shall also have some questions that we shall be given information and we do work by ourselves. So the first example, or the continuance of what we looked at, this example is, let me call it my example number one. The particle of mass, the particle of mass 2 kilograms, 2m kilograms, rests on a rough plane, inclined at tan inverse of 3 mu to the horizontal, where mu is the coefficient of friction, between the particle, and the plane, between the particle and the plane. First up, the particle is acted upon, by a force, P, acted upon by a force P, P newtons. Part A, given that a force acts along the line of the greatest slope, and that the particle is on a point of sliding up the plane. The particle is on the point of sliding up the plane. Show that the maximum force required to keep the particle in equilibrium is P max equals to 8 mu mg out of the square root of 1 plus 9 mu squared. Part B of the question, given that the force acts horizontally, in the vertical plane, through the line of the greatest slope, of the greatest slope, and that the particle is on a point of sliding down the plane, show that the minimum force required to maintain the particle in equilibrium is P minimum is equals to 4 mu mg over 1 plus 3 mu squared. So that is the question we are having. That is our problem that needs us to solve it. And I really assure you that this is an easy question if well interpreted. This is an easy question if it's well interpreted. Are we through with copying it?
Yes.
Okay, so that is the question we are having. And the solution to this question, it will be after you have sketched. That is when you can easily see and tell what is required. Okay. They have said that the particle of mass 2 m kilograms rests on a rough plane inclined at tan inverse of 3 mu. So let me first sketch this. We're beginning with part A. The particle let me assume that my angle of inclination is alpha because they have given it to me as tan inverse of mu, but let me put it as alpha. This is my body of 2 m kilograms. If the body is of 2 m kilograms, then its weight is 2 mg. 2 mg. This body has got several forces acting on it. So we shall have the normal reaction of the body and the component of this weight, which is going to be 2 mg cos alpha. And then we shall have 2 mg sine alpha, 2 mg sine alpha. But they've told me that given that a force acts along the line of the greatest slope and the particle is on the point of sliding up the plane, meaning that this force is moving this particle up the plane. So if that force is P, if it is at the point of moving up the plane, then it means that the frictional force will be moving it down. So if it is at the point of moving up, then the frictional force will be acting downwards. So I may say this is my F. Am I right? Am I okay with you?
It is okay.
So implying that if we are to resolve parallel to the plane, or if we are to resolve along the plane, resolving forces along the plane. What will be the force along the plane? I have this force P, so it's going to be P is equals to F plus 2 mg sine of alpha. Implying that my P is equals to F is mu R plus 2 mg sine alpha. But if you resolve perpendicular to the plane, resolve forces perpendicular to the plane, you'll have force R equaling to 2 mg cos alpha, implying that our P, if you substitute R into equation 1, it means that our P is going to be mu 2 mu mg cos alpha plus 2 mg sine alpha. But remember, my angle of inclination, they have told me that the angle of inclination is tan inverse of 3 mu, meaning that my alpha, which is the angle of inclination, is equals to tan inverse of 3 mu. So if alpha is tan inverse of 3 mu, then it means that tan alpha is equals to 3 mu. I'm trying to bring it out in a way that we should understand it. If tan alpha is equals to 3 mu, by Pythagoras theorem, this is like 3 mu over 1. So you can, mean that this is opposite, this is adjacent. So you can draw a simple triangle to see what others are equal to. If this is my alpha. So tan alpha is 3 mu. So we shall have opposite of adjacent. So the opposite is 3 mu and the adjacent is 1. So if I need this side, it will be this squared plus this squared under root, which will be the square root of 1 plus 9 mu squared. 1 plus 9 mu squared, implying that for this case, we can get what cos alpha is equal to, and cos alpha is going to be equal to adjacent over hypotenuse, which is going to be 1 over the square root of 1 plus 9 mu squared. And sine alpha is the opposite of hypotenuse, which is going to be opposite 3 mu out of hypotenuse, which is the square root of 1 plus 9 mu squared. Is it okay?
Yes, it is okay.
So if this is okay, then it means that my P, I'm going to substitute directly here. It's going to be 2 mg times mu. Okay, I can say 2 mg mu. Then instead of writing cos alpha, I'll put 1 over, I'll put 1 over 1 plus 9 mu squared under root then plus 2 mg. Instead of writing sine alpha, I'll write 3 mu over root of 1 plus 9 mu squared. So this is going to be 2 mg mu over 1 plus 9 mu squared under root plus, this is 6 mu mg, 6 mg mu over the square root of 1 plus 9 mu squared. And looking at this, since the square root is the same, rather since the denominator is the same, you add 2 mg mu plus 6 mg mu, it gives 8 mg mu or 8 mu mg out of the square root of 1 plus 9 mu squared. And that is the answer that was required. Hence our P max is going to be equaling to, I write it the way it was given, 8 mu mg out of the square root of 1 plus 9 mu squared. Is that okay?
It is okay.
Then let's go to part B. Let's go to part B and we see how it's done. Part B, they told us that given that the force acts along, it acts horizontally in the vertical plane. When the force acts horizontally in the vertical plane, so let's see how we come to this. Given that the force acts horizontally in the vertical plane through the line of the greatest slope. So still here, we shall have to first sketch. Still the angle of inclination, I'm calling it alpha. This is my body. Still 2 mg as the weight. I do the components. So we have 2 mg cos alpha, and this is R. Of course, here we shall have 2 mg sine alpha. They told us, given that the force acts horizontally in the vertical plane through the line of the greatest slope, and that the particle is on the point of sliding down. So it means that if the particle is on the point of sliding down, then the frictional force is acting upwards. But they have told us that the body is on the point of sliding down. If the body is on the point of sliding down, what do we do? If the body is on the point of sliding down, but we have an horizontal force. We've gotten an horizontal force acting through the line of the greatest slope. So we shall have components drawn, because if this force is P, shall have components drawn with respect to that force. Okay, so we shall have our, of course, here the angle will be also sine alpha. So here we shall have P sine alpha, and here we shall have P cos alpha. So that if I'm resolving along the plane, I'm going to have P cos alpha plus the frictional force, and should be equal to 2 mg sine alpha, implying that P cos alpha plus mu R is equals to 2 mg sine alpha. If I call this one my equation 1, then perpendicular to the plane, resolve perpendicular to the plane, we shall have perpendicular forces. We shall have P sine alpha plus this force 2 mg cos alpha equaling to R. So we shall have our R here equaling to P sine alpha plus 2 mg cos alpha. And if you substitute R into equation 1, we shall be having P cos alpha plus mu R. So it will be mu P sine alpha plus 2 mu mg cos alpha. So this is it. P cos alpha plus mu into R. So I've multiplied mu here. Mu P sine alpha, 2 mu mg cos alpha. And this is supposed to be equal to, 2 mg sine alpha. Implying that those ones with the P, I can maintain them this side. And I bring this one this side. So I'll be having P into cos alpha minus mu sine alpha, and this should be equal to, I brought this one this side, so 2 mg is common, so 2 mg into sine alpha minus mu cos alpha. Interesting. So I substitute those values of cos alpha as I got them. So it will be P into, we had gotten cos alpha as 1 over root of 1 plus 9 mu squared minus mu. Then sine alpha, we had said that sine alpha was 3 mu. So when you multiply mu, it will be 3 mu squared out of sine alpha, which is that, rather 3 mu squared out of 1 plus 9 mu squared is equals to 2 mg over sine alpha. Sine alpha was 3 mu over the square root of 1 plus 9 mu squared minus mu cos alpha. Cos alpha was 1 over, so it will be mu over the root of 1 plus 9 mu squared. Interestingly, this is going to be equal to, it is going to come to, when you look at this, actually this is supposed to be a plus. This is supposed to be a plus because I factorized out P remaining with cos alpha plus sine alpha. So it is supposed to be a plus. And this one will come to P into 1 plus 3 mu squared over root of 1 plus 9 mu squared equaling to 2 mg into 3 mu minus mu, it will be 2 mu over root of 1 plus 9 mu squared. Wow, so this one is going to be equal to, you see, 1 plus 9 mu squared is available on either side, so it is going to cancel here and here. I've cancelled it, so it is no longer there. So I'm going to have my P into 1 plus 3 mu squared is equals to 4 mu mg. Well, this is 2 times 2, so it is 4 mu mg. But we're interested in P. We are interested in P. So our P is going to be 4 mu mg out of 1 plus 3 mu squared, making it P minimum as 4 mu mg out of 1 plus 3 mu squared, as it was required. Is it okay?
Yes, it is okay.
So that's good, and you can give it more time and you go through it well. It can take it through. You can get the answers. And get it well. So can we do another proof?
Yes.
Our number two. A particle of weight W is at rest on an inclined plane under the action of force P acting parallel to the line of the greatest slope. Of the plane in an upward direction. The angle of friction between the plane and the vertical is theta, and the angle of inclination of the plane to the horizontal is 2 theta. Show that a P max is equals to W tan theta into 4 cos squared theta minus 1, 2 will be minimum is equals to mu W. So that's what we are having. And after this, I will give you questions that we shall try that involve not proofs, but instead calculating for the values we are supposed to be getting. So that is what we are having. And let's see how best we can make it. Let's see how best we can make it. We are given that the particle is of weight W. Well, if the particle is of weight W, it's these proofs that make us understand the general thing about this plane. So the particle is of weight W, and they told us that the angle of inclination is 2 theta. So we're having the angle of inclination as 2 theta, and I'm having the particle of weight W. So if you have the weight as W, you don't need to say WG because it's already weight. So it has gotten the normal reaction. You have to use a ruler throughout. So it means that this component will be W cos theta, that cos 2 theta. This is our normal reaction. And this one here is W sin 2 theta. They told us that a particle rests on an inclined plane, and they're saying that it is under the action of particle P acting parallel to the line of the greatest slope of the plane in an upward direction. So if it is acting in an upward direction, then it means that we have maximum force moving this body up. If the body is moving up, then the frictional force will be opposing the motion of the body. Now, this one would mean that by resolving along the plane, we shall be having P max equal to W sin 2 theta plus the frictional force. So P max is equal to W sin 2 theta plus mu r. But when we resolve perpendicularly or perpendicular to the plane, we have that r is equal to W cos 2 theta. implying that if we substitute here, we shall have our P max as equal to W sine 2 theta plus mu, then instead of R, I shall write W cos 2 theta. Remember, they have told us that the angle of friction is theta. The angle of friction is theta. But we know previously that mu, that theta, which is that angle of friction they're talking about, theta, is the same as tan inverse of mu. Implying that tan theta is equals to mu. That is what it means. So what am I going to do? It would imply that my P maximum would be going to be equal to, from here, it's going to be W sine 2 theta plus mu, but mu is tan theta because I have to bring everything in terms of theta. So tan theta times W cos 2 theta. Now, either side I have W. Can I put out, because in my proof, what they want me to prove, they want my W tan theta out. So can I factorize W tan theta out? If you factorize it out, this expression doesn't have tan theta. Meaning that we shall remain with sine 2 theta over tan theta. So that when you multiply, it cancels and you go back to normal. Then here plus, we shall add cos 2 theta. This is going to be equal to W tan theta. We bring in the trigonometric ratios. Sine 2 theta can be expressed as 2 sine theta cos theta, 2 sine theta cos theta. But then we are dividing by tan theta, which tan theta is, so it would be divided by sine theta over cos theta, which is the same as times cos theta over sine theta. Because sine 2 theta itself is 2 sine theta cos theta, divided by tan theta, which is sine theta over cos theta. So may have multiplied the reciprocal cos theta over sine theta. Then plus cos 2 theta, you can express it in in 3 ways, by the way. It can be cos squared theta minus sine squared theta. It can be 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. But when you look at what we have in the brackets, we have cos squared theta. So it has to be expressed as cos squared theta, which is 2 cos squared theta minus 1. That is from trigonometry. So this is going to be equal to W tan theta into sine theta will go with sine theta, so we shall have 2 cos squared theta. 2 cos squared theta plus 2 cos squared theta minus 1. So the P max is going to be equaling to W tan theta into 2 cos squared plus 2 cos squared, that is 4 cos squared theta minus 1. As simple as this. Is it okay?
Yes, it is fine.
Then part 2, they want us to look for P minimum. They want us to look for P minimum. All right. Now, when we said P minimum, the maximum force would be moving the body up, meaning the frictional force would be opposing it. But we only need the minimum force. Minimum force, it means that even the frictional force will constitute to that minimum force. Let me sketch it and you see. For part B, you sketch it well. Two theta. The weight is W. And this is W sine 2 theta. And this is R. This is my force, P minimum. When we say minimum force, if it is not the horizontal force, and we say minimum force, then the frictional force would be constituting it. So we have our F here. Basically, in a case where you're having the force required to move the body up, if it is the force required to move the body up, we are going to do some application example whereby we shall be finding the force acting parallel to the plane that will prevent the body. It's as if we are preventing the body from sliding down. So if we are preventing the body from sliding down, it means that this body was already moving up, and prevent it from sliding down, we assume that the frictional force is constituting to the other force that is trying to move the body up. So for minimum force, both the frictional force and the body, rather, and the force are acting up. So now for this case, when you are resolving, we shall have that P minimum plus F is equal to W sine theta. So P minimum plus F is equals to W sine theta. But I'm interested in P minimum. So P minimum.
Isn't it W2 sine?
Oh, yeah.
W sine 2 theta.
Sine 2 theta. So it is going to be W sine 2 theta minus F, which is mu R. So implying that here, this is going to be W sine 2 theta minus mu. My R would be, after resolving perpendicular, it would be W cos 2 theta. So this is going to be, I can move out. I can move out mu W, because my answer, they just want mu W only. So we have to reduce all these things to mu W. So let me move it out. Mu W into, this one here is going to be sine 2 theta over mu. So that when I multiply, I come back to this. Then minus mu W is already out, so minus cos 2 theta. Okay, so this is going to be mu W into sine 2 theta But remember mu, we saw that it's the same as tan theta. Then minus cos 2 theta, which is the same as mu w into this one here. The whole of this one, we had already seen how it is equal to in the previous summary. This is 2 sine theta cos theta times cos theta over sine theta, which brings us to 2 cos squared theta. All of that one reduces to 2 cos squared theta. We had already seen how this one reduced in the previous. Then minus cos 2 theta. Now, but we need to know we can as well express cos 2 theta as 1 minus 2 sine squared theta. I'm trying to do my best to make sure that I remain with the 1 here because I'm interested in 1, because the answer needed is mu w. So it would imply that my P minimum is equal to mu w into 2 cos squared theta minus cos 2 theta, which is 1, minus 2 sine squared theta. So this is going to be P minimum is equal to mu w into 2 cos squared theta minus 1 plus 2 sine squared theta, which is the same as mu w into, I can factorize out 2 for this and this. So I can say 2 into cos squared theta plus sine squared theta, then overall minus 1. This is the same as mu w into 2 into cos squared theta plus sine squared theta is 1 minus 1, which is going to be equal to mu w into 2 minus 1, which is 1. And therefore the P minimum is equals to mu w. Is it okay? With a proof, you must get an answer. Is it okay?
What about 2 cos squared theta plus 2 sine squared theta? Would it form something?
What about what?
2 cos squared theta plus 2 sine squared theta.
I reduced it here. 2 cos squared theta?
I'm saying if they are considered together.
No. You would have factorized out a 2, still reduced to 1, because you cannot add them to get a different thing. Okay? Okay?
Mm.
So first tell me if I should do another proof.
We can do another one.
Okay, so now let me read this. A particle of mass m, a particle of mass m kilograms is placed on a rough plane, is placed on a rough plane, is placed on a rough plane placed on a rough plane of inclination 30 degrees. of inclination 30 degrees, full stop. Given that the angle of friction, is lambda greater than 30 degrees, comma, show that the minimum force required, required to move the body up the plane First, you got to move the body up the plane is given by a half mg cos lambda plus √3 sin lambda, full stop. Continuation. If this is 3 times, the least force, if this is 3 times the least force that would cause the body to move down, this is 3 times the least force that would cause the body to move down, comma, show that lambda is equals to tan inverse of 2 over √3. Are we there?
Yes.
Let's work out the solution. They have given us very many statements. Which statements we have to work about? We have to work about those statements. A particle of mass m kilograms. Whatever they tell me, I do. A particle of mass m kilograms. So I have my particle of mass m kilograms. So the weight is mg. It's based on a rough plane of inclination 30 degrees. I have my 30 degrees. Given that the angle of friction is less than 30. So before I talk about that, we put these components here. This will be mg cos 30 degrees, and this would be the normal reaction, and this would be mg sine 30 degrees. So they are saying that the angle of friction is less than 30. Show that the minimum force required to move the body up the plane. So I would first let, before I do anything, let P be the force that would take the body up the plane, that would take the body up the plane, that would take the body up the plane, given lambda, right? Given lambda greater than 30 degrees. So it means that that force P is acting, but at a certain angle theta. So if the body is really moving up the plane, then the frictional force would be moving downwards, F. Now, if the body is moving up the plane, then here we shall be having the horizontal. I'll be having the horizontal component and the vertical component of P, whereby automatically this would be P sine theta. And here I will be having P cos theta. Summarize the resolutions along the plane. We shall have F plus mg sine 30 is equals to P cos theta. So meaning my P cos theta is equals to F plus mg sine 30. Implying that P cos theta is equals to mu R plus mg sine 30 degrees. Then perpendicular to the plane, shall have P sine theta facing up with R summing to mg, equaling to mg cos 30. So we shall have P sine theta plus R is equals to mg cos 30. Implying that here my R is going to be equal to mg cos 30 minus P sine theta. And then now I can substitute my R into equation star. Substitute R into equation star. This one will be P cos theta is equals to mu R. So it is mu times this. So it's going to be mu mg cos 30 minus mu P sine theta, then plus mg sine 30. I've just substituted this value into this. So I can bring those of P together so that I correct like terms. And here it is, I can bring P, mu P sine theta, so that I have P into cos theta plus mu sine theta is equals to, here I can factorize out mg, else you can leave it and maybe work on it later. So we shall have mu mg equals 30 plus mg sine 30 degrees. Yeah, looking at this mu, we know what it means. The other side, we say that mu is the same as sine lambda over cos lambda, if you have to remember from our first lesson. P into cos theta plus lambda, which we say that it is sine lambda over cos lambda, then times sine theta, right? And this is equal to mu. I can factorize out mg. Factorize out mg. Here, you'll be left with mu. But cos 30 is 0.8666, which is root 3 over 2. Plus sine 30 is a half. So here it is going to be P into it is P into cos theta cos lambda plus sine theta sine lambda. Over cos lambda is equal to mg mu root 3 over 2 plus a half. So cos theta cos lambda plus sine theta sine lambda, this one reduces to P. Theta minus lambda, this is an expression of theta minus lambda. All right. All right. Let me say over cos lambda. Okay, I can multiply lambda this side. I can multiply cos lambda here. All right. So I can say P cos theta minus lambda is equal to let me leave this one as cos lambda here is equal to mg. I can bring in mu here also. Mu is the same as sine lambda over cos lambda, then root 3 over 2 plus a half. So you're going to have P cos theta minus lambda over cos lambda is equal to, I can move out a half. Remember, this is LCM cos lambda. So it is going to be, if I factorize out a half this side, it will be a half mg. I'm left with the root 3 sine lambda plus, since the LCM is cos lambda, you will divide it here, so it will be cos lambda here. Out of cos lambda. Cos lambda and cos lambda will cancel, so we shall have P cos theta minus lambda is equal to a half mg root 3 sine lambda plus cos lambda. All right, but I'm interested in P. So I'm going on with this P. I'm going on with this P. So it is going to be, let me record this, the other step. It was P cos theta minus lambda is equal to a half mg with 3 sine lambda plus cos lambda. So our P is going to be equal to a half mg. All right, it's going to be a half mg into root 3 sine lambda plus cos lambda. We divide by cos theta minus lambda. But remember, they want us to show that the minimum force. So for P to be minimum, you have to quote that if that P is to be minimum, then it means that cos theta minus lambda should be equaling to 1. So if cos theta minus lambda is equal to 1, then it means that our P minimum is going to be equaling to a half mg into root 3 sine lambda plus cos lambda. And that was required like that. That was required like that. So let's do the other part that constitutes to this. The other next part, they are saying that if this is 3 times the least force to cause the body to move down, okay. If this is 3 times the least force, so now we need to look for that least force that would move the body down. And then they are saying that if this, what we have gotten is 3 times the least force. So implying that if I let maybe my P prime to be the least force that would move the particle down, now I'll be like this. The angle of inclination is 30 degrees. This is MG. This is MG cos 30. Normal reaction R. MG sin 30. So if the body would be moved, if the body is to move down, then the frictional force would be moving up. And I'll be having my force P, but still I have to resolve it. So now, this I called it P prime. Well, that's my force P prime. So implying that now the body is to move down. So this will be P prime for theta. If I call this one theta. All right. And this will be P prime sine theta. So now I will get the force also there. But that force will be 3 times. No, the other force we have gotten at first would be 3 times the force we shall get here. And then we prove the value of lambda. Okay, so now this would mean that if I resolve along the plane, then I would have F is equal to P prime cos theta plus mg sine 30. Implying that P prime cos theta, because I'm interested in P prime, is equal to F, which is mu r, minus mg sine 30. Perpendicular to the plane, I will have P sine theta plus r. In other words, r plus P prime sine theta should be equaling to mg cos 30. Implying that my r here is going to be mg cos 30 degrees minus P prime sine theta. So looking at all this, if I substitute the value of r into equation 1, okay, substitute r into equation 1, what are we going to be having? We shall get P1, rather P prime, cos theta is equal to mu r, so it will be mu mg cos 30 minus mu P prime sine theta. Then minus mg sine 30. When you bring this P this side, it's going to be P prime into cos theta plus mu sine theta is equal to mu mg cos 30 minus mg sine 30. You know what mu is equal to? Okay, so you substitute for mu as sine lambda over cos lambda, then you multiply. So it is going to be P prime into cos theta cos lambda plus sine theta sine lambda, this side, out of course, cos lambda is equal to substitute, factorize out mg out. Factorize out mg, here it is going to be mu cos 30, but mu is the same as sine lambda over cos lambda. So you'll take the LCM either side. Still here, you're going to have, remember, cos 30 is a half. So it's going to be a half. Actually, it is root 3 over 2. Root 3, then sine lambda minus a half cos of lambda, everything we shall divide by cos lambda. Either side substitute for the value of mu as sine lambda over cos lambda. Well, so this is going to be equal to P prime cos plus sine, that is cos theta minus lambda is equal to, if you factorize out a half here, it will be the cos will go cos lambda and cos lambda. So we shall have a half mg, here we've left with the root 3 sine lambda minus cos lambda. Wow. So our P prime is going to be equal to a half mg 3 sine lambda minus cos lambda. We shall divide everything by cos theta minus lambda. But if you are to get the minimum force, or the least force, okay? So the least force, let me call it the minimum still, it's going to be equal to, this one will be 1. So it is going to be a half mg root 3 sine lambda, but now minus cos lambda. But they told us that the least force is equals to 3 times so the force we got at first is 3 times the force we've just gotten. So by applying that, we are going to get the answer. So the first answer we got, are we there together?
Yes.
I'm rubbing off. Can I rub off? Hello. Hello. So for this case, since we know that what we got at first is 3 times what we've gotten, then it means that what we got at first, which was mg over 2 or a half mg root 3 sine lambda plus cos lambda is equals to what you've just gotten times 3. So it is 3 times a half mg root 3 sine lambda minus cos lambda Then now, mg over 2, either sides will cancel. So we shall have root 3 sine lambda plus cos lambda is equal to 3 times root 3 sine lambda minus cos lambda. Expand the bracket here, so we shall have root 3 sine lambda plus cos lambda is equal to 3 root 3 sine lambda minus 3 cos lambda. When you bring it this side, it will be 4 cos lambda is equal to, this is a 3 root 3 sine lambda minus root 3 sine lambda. So we shall be left with the 2 root 3 sine lambda. You can divide so that we remain with the tan. You can divide by cos either sides. So you'll have 4 over 2 root 3 is equal to sine lambda over cos lambda, which is tan lambda. Implying that tan lambda is equals to, this one will reduce by 4, 2, by 4, by 2, 1, by 2, 2. So it will be 2 out of root 3, implying that our lambda is equals to tan inverse of 2 out of root 3. And that is as it was required. That is as it was required. So questions are too many. Questions are too many. But if I'm to give you a clue, unless the force is mentioned to be acting parallel to the plane, we take it to be inclined at an angle to the plane. If it is not mentioned to be parallel to the plane, if it is not mentioned to be parallel to the plane, then we take it to be inclined at a certain angle to the plane. So this is a question that I want every viewer to do. A plane is inclined at an angle 20 degrees to the horizontal, and a mass of 100 kg is to be dragged up. The coefficient of friction being 0.25. Find the direction. And the magnitude of the least force. Now, a clue. They have not told us that the force is acting parallel to the plane. Therefore, we shall take it to be inclined at a certain angle, like theta. All right, so theta will be the angle of inclination of the force. And since the particle is being dragged up, then the frictional force will be acting downwards. And another thing I want to remind you is that they have given us the coefficient of friction, 0.25. And you clearly know that mu is the same as tan lambda. That is why we get sin lambda over cos lambda. Meaning that you can easily get lambda, because lambda will be tan inverse of mu. So let me see if my viewers will get the minimum force as 548.523 newtons. And the direction theta as 14 degrees. We shall begin from here. I'll begin by doing the correction of this number in case, and then we progress. I wish you all the best, guys. God bless you.